Ever wondered how we make sense of vast amounts of data around us? The answer lies in statistics and probability. Let's imagine our world as an infinite ocean of data. Every day, we're bombarded with information, from the number of steps we take to the temperature outside, from the stock market fluctuations to the latest trends on social media. This data, in its raw form, is like undecipherable codes. But when we apply the magic of statistics and probability, we turn these codes into meaningful insights that help us understand the world better. But what exactly are statistics and probability? Well, in the simplest terms, statistics is the science of collecting, analyzing, interpreting, presenting, and organizing data. On the other hand, probability is a mathematical tool used to study randomness and uncertainty. Together, they form a powerful duo that helps us make sense of the randomness in our world. Now, the field of statistics and probability is vast and exciting, with numerous areas to explore. However, today we're going to focus on four major ones: descriptive statistics, inferential statistics, probability distributions, and hypothesis testing. Descriptive statistics is like the magnifying glass that allows us to examine each piece of data individually. It's all about summarizing and interpreting data to provide a comprehensive snapshot of it. Inferential statistics, on the other hand, is like a crystal ball. It helps us make predictions about larger populations based on samples. It's the bridge that connects our sample data to the wider world. Then we have probability distributions, which are like roadmaps that guide us through the landscape of possible outcomes. They help us understand the likelihood of different outcomes. And finally, hypothesis testing, our scientific method in statistics. It's the tool that helps us make decisions and draw conclusions based on our data. These are the four pillars that hold up the fascinating world of statistics and probability. Each one plays a crucial role in helping us navigate through our data-filled world. Stay tuned as we dive into our first topic, descriptive statistics. So what is descriptive statistics? It's all about summarizing and understanding data. Imagine you're in a room full of people. You want to know more about them, but it's impossible to get to know each person individually. This is where descriptive statistics comes in. It's like a social butterfly, fluttering around, collecting tidbits of information, and then summarizing it for you. Let's dive into the two key components of descriptive statistics. First, we have measures of central tendency. This isn't as daunting as it sounds. Simply put, these are ways to find the middle ground. They include the mean, which is just a fancy term for average, the median, which is the middle value when all the data is laid out in order, and the mode, which is the most frequently occurring value. It's like trying to find the most common theme at a costume party. Is it superheroes, pirates, or perhaps unicorns? Now imagine you're at that party and you want to know how varied the costumes are. Are they all quite similar, or is there a wide range? This is where our second component, measures of dispersion, comes in. It includes the range, which is the difference between the highest and lowest values, the variance, which tells us how spread out the values are from the mean, and the standard deviation, which is like the variance's less complicated sibling. It measures the average distance of each value from the mean. Consider a bag of mixed jelly beans. The mean could tell you the average color, the median could tell you the middle color when arranged in some order, and the mode could tell you the most common color. Meanwhile, the range, variance, and standard deviation could tell you how diverse the colors are. Together, measures of central tendency and dispersion paint a comprehensive picture of our data. They allow us to capture the essence of the information, much like a well-taken photograph. With descriptive statistics, we can summarize and understand data better. But what if we want to make predictions? That's where inferential statistics comes in. Inferential statistics, as the name suggests, allows us to infer or make predictions about a population based on a sample. But hang on a second, what exactly is a sample? Well, in the realm of statistics, a sample is a selection of individuals or data taken from a larger population. Imagine you're a coffee lover, and you're trying to determine the best coffee beans in the world. It's impractical and near impossible to taste every single type of coffee bean out there, right? So you select a handful of different types or a sample, and base your judgment on that. That's sampling in a nutshell. Now, it's crucial to ensure that our sample is representative of the population we're studying. If we only sampled coffee beans from South America and ignored those from Africa or Asia, our inference would be biased and inaccurate. A representative sample is like a mini version of the larger population, embodying its characteristics and diversity. Once we have a good sample, we can start making predictions with a certain level of confidence. This is where the concept of confidence intervals and margin of error come into play. Think of a confidence interval as an educated guess about a population parameter, such as the average weight or height in a group of people. It's a range of values we're fairly sure our actual value lies within. Margin of error, on the other hand, gives us an idea of how far off our estimates could be. The smaller the margin of error, the closer we are to the true value. So if we say that the average height of women in a certain region is 5 feet 4 inches, with a margin of error of 2 inches, the true average height could be anywhere between 5 feet 2 inches and 5 feet 6 inches. Inferential statistics gives us the power to predict and make informed decisions. But for that, we need to understand probability distributions. Probability distributions are like a roadmap, guiding us on the likelihood of different outcomes. Let's take a moment to appreciate the magic of probability distributions. They're the heart of statistical analysis, giving us a comprehensive view of all possible outcomes and their likelihoods. They help us make sense of the world around us, translating randomness into something we can comprehend, predict, and plan for. Now, you might wonder, what exactly is a probability distribution? Well, imagine you have a bag of multicolored candies. You reach in without looking and pull one out. The probability distribution is a way to represent the chances of drawing each color of candy. It's a mathematical function that provides the probabilities of occurrence of different outcomes in an experiment. There are several types of probability distributions, but let's focus on two of the most common ones: the uniform distribution and the normal distribution. The uniform distribution is the simplest form of probability distribution. It's like a flat line, where all outcomes are equally likely. Think of rolling a fair 6-sided dice. The chance of landing on any one side is 1 in 6. No side is more likely than the others. On the other hand, the normal distribution, also known as the bell curve, is slightly more complex. It's characterized by its symmetric bell-shaped curve, where the mean, median, and mode all coincide at the peak of the curve. A simple example of normal distribution is the heights of people. Most people are of average height, while fewer people are very short or very tall. These probability distributions, among others, help us understand and predict the world around us. They guide us to make informed decisions, whether it's in business, science, or even everyday life. With probability distributions, we can predict the likelihood of outcomes, but how confident are we with our predictions? That's where hypothesis testing comes in. Hypothesis testing is like a courtroom trial for our predictions. Just as a defendant is presumed innocent until proven guilty, a statistical hypothesis is assumed correct until the evidence suggests otherwise. So how does this courtroom drama unfold? Well, it all begins with stating our hypotheses. The null hypothesis, akin to the defendant's assumed innocence, is our default stance. It's the hypothesis we're testing for validity. The alternative hypothesis, on the other hand, is the claim we're making against the null. It's what we believe to be true. Once we've set the stage with our hypotheses, we choose our significance level. This is our threshold for doubt, our statistical line in the sand. Commonly, we set a significance level of 5%, meaning we're willing to accept a 5% chance of wrongly rejecting the null hypothesis. Next, we move on to calculating the test statistic. The test statistic is our evidence, our proof. It's a measure that helps us decide whether to accept or reject our null hypothesis. Different types of data require different test statistics, but the idea remains the same. We're looking for evidence. Finally, it's decision time. If our test statistic falls within the critical region, a range of values determined by our significance level, we reject the null hypothesis in favor of the alternative. We've found sufficient evidence to suggest that our null hypothesis is likely false. If it doesn't, we fail to reject the null hypothesis. Notice we don't say we accept the null hypothesis. Just like in court, we can't prove innocence, only fail to prove guilt. Let's illustrate this with an example. Suppose we have a coin and we want to test if it's fair. Our null hypothesis would be, the coin is fair, and the alternative, the coin is biased. We flip the coin 100 times, and if we get a significantly high number of heads, say 70 or more, we might reject the null hypothesis and conclude the coin is biased. With hypothesis testing, we can confidently make decisions based on our data. So, we've journeyed through descriptive statistics, digesting raw data into meaningful insights. We've navigated the predictive power of inferential statistics, allowing us to make educated guesses about larger populations. We've explored the magic of probability distributions, illustrating the possible outcomes of a random variable. We've gained confidence through hypothesis testing, challenging assumptions with empirical evidence. These aren't just mathematical concepts. They are powerful tools that help us understand patterns, predict outcomes, and make informed decisions. Remember, statistics and probability are not just about numbers. They're tools that help us make sense of the world around us. Thanks for joining this enlightening journey.